Okay, hello everyone. In this workshop, we're going to try to build a simple smart contract with Cairo, and we try to deploy on Starknet. Also, I will show you the tool chain required to start developing in Cairo. So there is a repository on the Nethermind GitHub with all the code that we're going to use in this workshop and all the bash commands that you're going to need. So we just need to start by installing ETHGlobal, which is a package manager, and it's going to be very useful to manage the version of Scarb and Starknet Foundry. Scarb is a package manager for Cairo, and Starknet Foundry is the foundry as in Solidity, but for Cairo specifically. So the first command we're going to need is to install ETHGlobal. Of course, I have everything installed already, so okay. So I'm not going to need to install anything anymore. Right. Okay. Since ETHGlobal is already installed, it's going to tell me it's complaining. Next, we add a plugin with ETHGlobal. So first plugin we add is Scarb. It's going to complain again because Scarb is already on my system. And we install the latest Scarb. With ETHGlobal Scarb install, we can select whatever version of Scarb we want. In this case, we use the latest. Right? And we do the same with Starknet Foundry, which is the test suite for Cairo. Same. And okay, latest Foundry to install. Okay, and we're going to need Starknet, which is a library to declare and deploy Cairo contracts. Okay, so this is the tools. These are the tools that we are going to need to develop. And right now we can create a Cairo project. We can do it by using SMForge, which is Starknet Foundry, init, and a package name, and we can call it ETHGlobal. Okay, this command we create a repository with the dependency and some boilerplate code used for examples. Let's open it. Okay. So as you can see, we have a basic source folder which is supposed to contain all our smart contracts, a test folder with the tests. This is very important. Scarb toml is basically defining the package and the dependency. It's very similar to Rust, as you can notice. So we have the name of the package, the version. The edition is basically a set of, it's like a preload. So it's a set of library that you have included in your package, and from the Cairo core libraries. You can select this one, which is the most complete, or you can select a lighter one, which is 2407. But in that case, you will need to import manually the library that are missing. And then we have the Starknet version in the dependency. And for the dev dependencies, we have Starknet Foundry, version 30. Okay. There's a section with the scripts. And we want to also add a tool version file that is used by ETHGlobal. And here we can define Scarb version, in this case 2.8.2, and Starknet Foundry. Is 0.30. In case we want to use a different Scarb version with a different compiler, we can just change these values, and ETHGlobal will select automatically the version that we are going to use. It's very easy, and it's the best thing you can do using SDF. So let's try Scarb version 8.2 and and Forge version. Okay, let's have a look to the contract in the boilerplate. So to define a contract, we need to define an interface first, which is called trade. So we have just the function headers. We use tContrast state, which is a generic contrast state type. Here we got two functions: increase balance, self-explanatory, and get balance. Very easy. The next part is the actual contract. So we add Starknet contract decorator. We define a module name. I'm going to change this to hello ETHGlobal. And okay, we got the storage. In this case, balance, and the type is felt. And here is the actual implementation. We add the decorator ABI embed with 0. If we don't do this, this function will not be visible, will not be external, basically. So you cannot, they will not be able to call them. So we define embed with 0, and we call the implementation hello ETHGlobal. And this is an implementation of the generic trait above, so the interface basically. And here we use the contract state, which is the state of the contract, and we need to pass it as an argument to our implementation. Here we got two functions, the increase balance, so basically just increase the balance, and here we do self, which is contract state, balance, the storage, write the new balance here, and the get balance is basically reading from self the balance. If you see the difference here, how the contrast state is passed, when you have writing functions, so function that they change the state, you need to pass the contrast state as a reference. So it's going to be mutable, contrast state. When you just have a read function, which they don't modify the state, you just pass as a pointer, basically. You pass the contrast state as a pointer. Right, to compile, we simply do scarb build. Scarb build. Right. This will compile our contract in the target folder, and you're going to have two files. One is the Sierra, and the other one is the bytecode. Right, this is the contract class, which is actually the bytecode we're gonna deploy, and this is the Sierra. Let's format this. This is human readable. Sierra is an intermediate representation of the actual bytecode, and yeah. Anyway, okay, we got this. To run the test, so here there's already a couple of tests that the init command has created. As you can see, we are gonna import all the dependencies. Here we change the name. Okay, not the same. So we want to import the dispatcher and the dispatcher trait, which are used to initialize our contract after it's deployed. Same here. Okay, this is the function to deploy. We import Foundry dependencies, so to declare and the trait for the contract class, which allow us to deploy and declare. So on Starknet, before you deploy a contract, you need to declare the class on chain. So as you can see, here we declare the class of our contract, and we deploy after we deploy the contract class, basically. You see in this test, we mark as test. We deploy the contract. We create a dispatcher, which is basically the element that will allow us to call the deployed contract. And here we perform a call, dispatcher get balance, and this is a test. You can also have a failing test. To run the test, simply smforge test. It's a mismatch version here. All right, yeah. Oh, there we go, that's why. Okay. There was a mismatch version, so ASDF wasn't reading the correct Foundry version for the typo. So it's compiling the contract. Okay. Oh yes, that's a problem because we changed the contract name, right? So the contract now is called Hello ETHGlobal. So we need to change the name here. Okay, one other failed. Oh yeah, here too. We need to change this one as well. So the reason why I changed the name of the contract is because you cannot redeclare the same contract twice. So most likely this contract has been declared on Sepolia already. So if I don't change something, it's going to try to declare a bytecode that has been declared already, and it's going to fail. Okay, test passed. Let's go ahead and start deploying. To deploy, first thing, we need an RPC URL. In this case, I'm using Blast API, which you can find as a free RPC service. I recommend you to use the 0.7 version, which is the latest RPC. If you try to use a different one, it's going to fail because Starknet is using RPC 0.7. So we export Starknet RPC environment variable, so we don't have to add it all the time. Okay. So to deploy, we first need a signer, which is basically a key store to use with Starknet. Okay, Starknet signer key store new, and this will create a JSON file, no password in this case. I don't need that. And here we got our key store. You can deploy the key. You can save the key store everywhere you want. It doesn't really matter. So you got basically signing keys here. Second, we need to export the key store as a variable. Okay. And okay, second thing, we need to deploy an account. So the RPC here is pointing to Sepolia. We're going to need to declare an account first and deploy it on Sepolia to be able to deploy our contract. So it's asking our key store password. No password, okay. We got an account JSON. Here we got the public key. You want to keep these files, of course, hidden normally. Don't push them to GitHub. Okay, so we got an account, and now we need to deploy the account. Okay. Right. To be able to deploy the account, we need to found it first. So I already have some ETH on Sepolia. So I'm going to send some funds to my new account, which is not deployed yet. At 0.1. Right, that's too much actually. Okay, if you need some ETH, there's a few faucets around. You can find them. Just Google Starknet faucet. So it's going to tell you the account is not yet deployed. Do you still want to send the funds? Yes. All right, the transaction has gone through. Yep. Okay, so we're going back to. Right, so now it's been founded. We press enter. Let's try again. Yeah. Yeah, because the transaction failed. Let's try again. Okay. Yeah, last time with the time. Should be fine now. All right. Okay, the account is deployed, and it's going to tell you here its status changed from not deployed to deployed, and we know that it's deployed. Right, now we got an account. We can start by declaring the contract. We do Starknet, declare target dev, and we have. So what we need to declare is the contract class. Yeah. ETHGlobal. Hello. ETHGlobal contract class JSON. Declaring classes requires. Oh, sorry. I need to export the account. Yeah. I need to define account. Account JSON. Right, the class is declared, and we're gonna get back a class hash, which we are gonna use to deploy. Starknet deploy. The class hash as a parameter, and account again. Okay, the contract should be deployed. Now we can go to Voyager, which is the block explorer. And we swap to Sepolia. And we enter the new deployed account address. There we go. Okay, now we can read the contract here. So get balance, our get balance function. Let's query that. It's going to be probably 0. Yep. You can change the format of the data, and to write, we connect our wallet. I suggest you to create a wallet with either Argent or Bravos to be able to use this. Let's increase the balance, amount, 45, 54. Transaction is exactly like any Ethereum block explorer, basically. Okay. Should be good. Let's go back on read. Let's query. And our balance has been updated. That's all. Any questions? We got 2 minutes more. Yep. All good? Okay, guys. Thank you very much. I hope this was helpful. And I'll see you around. you.